Hello, welcome back to our coverage from AWS reInvent 2018. We are live with you from the Sands Expo here in Las Vegas. I'm joined by Randall Hunt at the far end of the desk. My name is Ian from the AWS Evangelism team, and I have two very special guests with me as well, who I'd like to invite to introduce themselves first of all.
I'm Werner Vogels. I'm the system administrator of a small bookshop.
I'm Tony Petrosian. I work on DynamoDB.
Awesome, and we're here in this next segment to introduce a new feature for DynamoDB. Before we do that, I think we should probably start by explaining what DynamoDB is. So Werner, can you talk a little bit more about what the service is and what kind of problems DynamoDB solves for our customers today?
Well, DynamoDB is a database built for internet scale applications, where you really require guaranteed or rock solid performance regardless of what kind of load you put on the database. Highly reliable, scalable, secure, and it's focused on the non-relational model. Yeah, and there's many sides to it. I think that's a key value as well as document-based. All of those are models supported by DynamoDB, and is used by most of our customers for their most demanding applications. And take something, for example, like a company like Supercell. When they launch a new game on day one, immediately millions of customers will be using their applications, and as such their database needs to scale to significant load. And I think DynamoDB has demonstrated over the years that it can really give rock solid, consistent performance. I think one of the things that we really tried to do from day one with DynamoDB is take away much of the management hassle that you normally have with a database. Yeah? If you look at how normally databases are, whether that's relational or non-relational, you have to manage your buffer pools, you have to manage connection streams, all these kind of things, just to get consistent performance out of your database. And when we designed DynamoDB, we looked at that and thought, why don't we then give them just an interface that says, and this is the consistent performance I want, and let AWS figure out how to achieve that. And I think DynamoDB has been one of the greatest success stories of AWS, both in terms of our most demanding customers are using it, and one of those most demanding customers is actually Amazon, the retailer itself, who uses DynamoDB all over the place.
You mentioned developers interacting with the service there. As a software developer, how do I go about integrating DynamoDB with my apps? What sort of mechanisms can I use to store and retrieve data from the service?
Well, the usual service interfaces that we've always built through APIs, making it very easy for you to sort of store and retrieve data. And even there's a mechanism almost already from day one where you can make a decision whether you want to have consistent versus eventually consistent reads. And we really expose that through the pricing model as well. Because, for example, for a consistent read, you need to read from 2 of the replicas. And as such, that comes at a higher cost, but it comes with more consistency. So we've given you an interface that really matches sort of how modern application development is being done.
Okay, what about the history of DynamoDB? When was the service conceived? What's the backstory? And how's the service evolved since its launch?
So I think there's a history before DynamoDB, which was called Amazon's Dynamo, which was, and if you actually come to my keynote on Thursday, you'll hear me talk more about the original story behind Dynamo, why we did this. But let's say we just did a deep dive at one moment about how we were actually using our databases. And the majority within Amazon.com was actually key value. We're using relational databases to do key value. You could see that because most of these queries are just a primary key and a single row was returned back. And about 70% of the operations, data operations within Amazon were key value. So we realized that we could actually build a dedicated database for that. We didn't need to use relational databases that could operate at scale and give consistent performance. That was, and we wrote a paper about that at one moment in 2007. And actually, we just entered the ACM Hall of Fame with this paper, because after 10 years, they become eligible for the Hall of Fame, and we just entered that one on the first try. So over time, we saw that our AWS customers were in need of a similar type of technology. And we had all these learnings from Dynamo inside, using it inside Amazon, as well as one of the earlier services in AWS, SimpleDB, had sort of similar capabilities. So the lessons from both of those databases came to life in DynamoDB when we launched that. I think that was in 2012?
2012.
Yeah. So, and these guys have been innovating like mad. I mean, the features that have rolled out since, secondary indices, global tables, DynamoDB streams, all of those are helping our customers build really complex internet scale applications that need consistent performance.
And continuing that theme, we've got something new to announce on DynamoDB today. So what are we announcing today here at reInvent on this service?
Well, actually, so one of the things that many of our customers have asked for, and as you know, 95% of our features and services come out of direct customer requests. So a particular a challenge that customers had is if they wanted to update multiple items in a table in a consistent manner, or even over multiple tables, that they wanted something like that was traditionally in databases like transactions. So today I'm very happy to announce that DynamoDB will have transaction capabilities for those who are looking for it.
Great.
Yeah.
So just turning to you, Tony, what use cases do these transaction capabilities enable for customers? What can customers now do that they couldn't do previously?
So what we've done is we've introduced two new APIs. One is for write transaction and one for read transactions. And with these, you can combine several updates within a single transactional API call and make the call, and you get an all or nothing characteristics that all succeed or all fail. And we have isolation level across transactions. You can do transactions across many items in one or more tables within a region in a single account. So if you want to update, let's say you have 3 items you want to update and they're in the same table, but you want to move points from one item to another item and you want to subtract something and add to something else, you can do it transactionally, so you're guaranteed that both will succeed or both of them will fail and you get a return code if something goes wrong. And it really helps developers write code a lot easier, where you don't have to have these crazy compensation code for dealing with errors. And you can also add conditions to the transactions. So if you want to take money from an account and add it to another account, you can check to see if there's sufficient funds. If not, you cancel the transaction. Yep. And as a developer, you don't have to do anything. Right? You just write your code and off you go.
And I think there's an important distinction to be made here in that DynamoDB already had batch operations built into the SDK. You could make multiple updates. But what is very different about this is, even though it's exposed through a similar interface, this is actually a transaction, just like you would get in another database. You can say, like, hey, I want you to not commit all of this until I'm sure it's all done.
Yes.
And it protects you across all the variants of failures that can happen across network systems.
I think in this mode, one of the nice things about it is that because it's an API call, you batch up all of your updates, deletes, or inserts as a single API call, and you make the call. And again, you get consistent performance. We're not trying to do conversational transactions where you say begin transaction and maybe you go to lunch and then the DBA is trying to find the hung transaction and kill it, and long-running transactions. And so it's all, again, in the spirit of DynamoDB, it's about consistent performance, and now you can have consistent performance with transactions.
Did we have to make underlying changes to the DynamoDB platform or technology in order to enable this? How is it built?
Well, as mentioned before, within a single item, you always had transactional characteristics for a single item. So what we have to do is make the transaction coordinate across many items, and the many items could be spread across many machines in a data center, sometimes thousands or tens of thousands, hundreds of thousands of machines. So we now have a fleet of transaction coordination systems, that is a distributed transaction control system that ensures that the transaction across all of the nodes that are participating in this API call are coordinated.
Okay,
and that's how it works.
What about billing for the service? How does pricing work? How does this affect the amount that customers will pay to use DynamoDB?
So there's no changes in the billing and the metering. Transactions do require more work, so we usually do 2 reads for a transaction, because
so
we have to we have to do a prepare and then we have to do the commit. So you end up getting charged. For example, if you do a transactional get, you will have to use 2 read units, because the first read unit will read it, prepare the transaction, the second one will commit the transaction. So basically, it's 2 requests worth of...
For those of you that might be new to DynamoDB billing, you are provisioning capacity units containing a certain amount of read throughput, so you're essentially consuming those capacity units more quickly by using this feature, right?
And if you think about, like, the eventually consistent reads requires half a unit, a consistent read is 1 unit, and a transactional read is 2 units.
And one of the really interesting components of read capacity units, write capacity units is some workloads are write heavy, some workloads are read heavy. But DynamoDB now has auto scaling on each one of those units independently.
Yes.
So if you have a table that you're committing everything to once, and maybe you're doing a small amount of write transactions, but you have 70,000 read throughput, you can do that very easily. And then when you're not using it, it'll scale right back down to nothing.
Yep.
Or not.
You mentioned across table support, so can I have transactions that update items that are in multiple tables?
Absolutely.
And can those tables be in multiple regions, or do they have to be in one
No,
region?
so transactions are limited to a single region within an account.
Okay.
So the blast radius is still protected in again, the spirit of Dynamo.
Okay, cool. I notice you've got something to show us on screen here, so maybe you want to talk us through that. Can we have the laptop up on the screen, please? Thanks.
Sure, so I have a little bit of a code here. Basically, this is a little app that we wrote as a demo. You think of a ride-sharing thing, and where we're sharing rides, and the two of us get in a car, and at some point have to deduct some money from your account and some money from my account and add it to the driver's account who was getting it. And so we want to be able to do these operations as an atomic unit, ACID transaction.
Yep.
So in this code, I'm preparing 3 updates. One is to update the Rider 1 account to reduce their balance because they have to pay for the fare. And then there's a Rider 2 account. So I'm preparing the second update. And then the third update here for the driver update is basically, the driver is the one who gets the additional money. So we prepare all of these updates. And then we have a single transact write item request here. So that's the new API call, transact write item, which basically takes an array of updates, deletes, or inserts that you've prepared and applies it. And so DynamoDB gets the API call and then goes out and then coordinates all of these updates. And when it's done committing all of them, it comes back.
With a success code in your application.
Yeah, with the success code. And you can add conditionals on all of these things. Like, if I don't have enough money in my account, then you can't go forward with this transaction. And so basically, transaction is canceled, saying, hey, condition didn't meet.
Yep, that'll back out the preset.
So you don't have to read and then try to do a write and hope that it worked or version it. You just do it all at one step.
So I noticed the code samples here in Java. Which AWS SDKs are supported? Is it going to be available on all SDKs?
Yeah, all of the...
One thing in particular that I'm super happy about is in the Python SDK, it's just Bodo. You go with Bodo like you normally would, and then you get the ability to define a context manager. So in Python, if you've ever written before, there's a statement called with. You define a context manager, and then you put a little colon, and you type everything you want to happen. So you define all the transactions that you want to do, and then the end of that block is your transaction. You don't have to do any extra work. It's extremely powerful.
We've got a couple of questions from the stream.
Is there support for rollbacks, by the way? So how do you implement your rollback?
So because it's API-based, if any of the condition within your transaction is false, then the transaction by default is canceled. And so there's no need for a rollback because we basically don't follow with the commit. Okay. We do the prepare, and if the transaction conditions aren't met, then we roll back for you. So you don't have to do a begin and a commit or rollback. Okay. You just load it all up as your conditions and submit the API.
Cool.
Questions we've got from the stream. Prime Java 1 guy asks, is this generally available or in preview, and in which regions is the service available from?
So it will be available in all regions. It's everywhere now. SDK will drop tomorrow for all of the AWS supported languages. So starting tomorrow, you can download the SDK and write code in any region you want.
Great, and presumably the documentation on the AWS website will be updated.
The documentation
by tomorrow as well.
will be out there. I think there's a great blog coming out for transactions. There's some examples, so it'll be ready tomorrow.
I think there's also, I don't know how often you get the chance to actually dive deep and see the DynamoDB query language in action. I know we have a pretty broad audience on the stream today. I don't know if we can go back, but one of the things that really makes DynamoDB super attractive as a developer is you define these condition expressions, and you're just defining variables, and then you fill in those values. So you're saying set balance. It's a very readable syntax. It's a very easy way to think about and structure your queries. It's not having to structure inner join on top of select foreign key from this other table. It's a much more fluid way of thinking about the way you write code and the way you instrument data and work with data.
The final thing I wanted to ask you about was the future for Dynamo. So a lot of updates in the last couple of years with things like global tables and streams preceding that, and now this transactions update. What do you think the future holds for DynamoDB? What areas of development are we looking at for the next couple of years?
So, our focus is to make DynamoDB as approachable for developers as possible, because we really think that this is a great developer tool, and so we're going to continue to improve on that front. And then one of the other things which is happening with Dynamo is our customer base is really diversifying. We have customers in financials, in manufacturing, in automotives, health, and so some of the features which we're building, like, I need GDPR, I need compliance, I need backup restore. So this is the stuff that we worked on. And then, so as our customer base diversifies, the requests and the asks from customers get more interesting. And we are going to stay true to the mission of Dynamo, which is going to be single-digit millisecond response time at any scale. And we're not going to do anything that compromises that promise of Dynamo. So it's going to be scalable, it's going to grow, and it's going to support more diverse workloads in more diverse industries.
One of the things
and as always, we're also working really hard to make sure that our customers actually have the lowest cost possible. So we do a lot of innovation, let's say behind the covers, to actually reduce costs for our customers, such that this becomes really, let's say, the transaction per dollar amount, or dollar per transaction amount, really drives down much lower than many of the relational databases out there.
Great.
One of the things that I also like about DynamoDB is that it improves without you as a developer having to do anything. So server-side encryption was originally an option, and now it's just enabled by default.
Yes.
It's just a thing that we can do with all of the different tables, and you get that additional compliance check, or you get that additional security without having to think about it or do anything. You're not provisioning certificates, you're not like making private AES keys or anything like that.
There are no maintenance windows for DynamoDB.
That's the truth.
You don't have to define a maintenance window, and it's not version, it just always works. So when we said, hey, as of now, all tables are encrypted, we have hundreds of petabytes of stuff back there. So it's taken us a long time to methodically go through and encrypt everything without a single customer noticing that we've gone through and have done all this work. And that's one of the beauties of as fully managed serverless database.
It's one of the beauties of managed services.
Point-in-time recovery and backup and restore and everything to the DynamoDB. And one of the amazing things is that it works for a database that's 10 megabytes, but it also works for a database that's a terabyte or more.
That's right, hundreds of terabytes.
Hundreds of terabytes.
We actually have a customer with a table which is in a 200 plus terabyte in size, in a single table with 2.5 trillion items in it. So, and when we do backups on that, they don't notice.
Wow.
So.
Yeah, and so many innovations in and around DynamoDB, we had to make sure that we don't break existing applications. I think launching new features such as transactions don't require customers that have existing code to make any changes.
Right.
And I think that's also the power behind DAX, the Dynamo Accelerator, which gives you basically an in-memory cache in front of Dynamo. Without it, you had to make any changes to your code. You just change the endpoint, and everything still works. You just get microsecond latency instead of milliseconds.
Yeah.
Great. There's just one more question from the stream that I'm going to take, and then I'm going to ask you just to share a little bit about when your keynote is, Werner. But the question here from Annie Swick says, now that you have transactions, multiple tables may be updated in different orders. Will you be able to address deadlocking?
So there will be no deadlocks. We do optimistic concurrency, so there will be no deadlocks. There will be no long-running transactions. There will be no open transactions. We'll support transactions without the pain and the suffering that comes for DBAs in the traditional systems. We manage transactions on behalf of you, and we'll drive transactions to completions, or we cancel and return an error to you with specific reasons why the transaction was canceled.
Okay.
And if you want to set the kind of stuff there to prevent that last right when scenario, you can just in your condition expression have something that says, hey, don't update this if something else has already happened.
Yeah.
And I like to believe that most customers, most developers will be using this for of all the asset parts. They will be mostly using it for the atomicity part, to be able to update multiple items, whether in a single table or multiple tables, as one atomic operation.
Excellent. So I'd just like to wrap up by asking you when viewers on the stream and here at reInvent can see your keynote this week. When and where will you be on stage?
On Thursday, I believe at 8:30 is when I start. Let people sleep in for half an hour longer. We'll have lots of great deep technical content. So where Andy mostly focuses on the business side and all the new products and announcements that we're making. If you come to my keynote, we'll do a really deep dive on AWS technology and talk about a lot of new stuff around serverless and Lambda.
Cool, and you can catch that here on twitch.tv/AWS as well. So we'll see you then.
Excited.
Bye-bye.
Thanks.